Let's move to the next question then. Which of the following rules or principles is responsible to rule out the existence of definite paths or trajectories of an electron? This is according to your Heisenberg's uncertainty principle. Yes, this is according to your Heisenberg's uncertainty principle, which you know the statement, that is choice D is the correct answer. Next question. Frequency of matter wave is equal to, frequency of a matter wave is equal to which of the following choices? Frequency and Planck's constant and kinetic energy are related as twice kinetic energy divided by Planck's constant h, that is choice B. Moving to the next question. Hatry is the atomic unit of energy and is equal to what? Hatry is the atomic unit of energy and it is equal to the value of choice B, that is minus 27.2 electron volt per atom. That is the relation between 1 Hatry and electron volt. Keep that relation in mind. You have to remember that relation. Next question. The potential energy of an electron in the second Bohr's orbit for helium plus ion is, okay, the potential energy of an electron, which electron in the second Bohr's orbit for helium, that means N1 will be equal to 2, N1 will be equal to 2 and N2 will be equal to 1 using the formula for Rydberg's formula, substituting and find out the energy. Energy will be equal to RH inside the bracket 1 upon N1 square minus 1 upon N2 square. N1 will be 2, N2 will be 1. Rydberg's constant value we have to substitute in terms of electron volt. You should get the energy as minus 27.2 electron volt. Choice B is the correct answer. Okay, so I am just telling you the formulas, I am telling you the substitutions and the calculations you have to do and verify if you find any doubts. But I don't think so there should be any doubts. The answer is absolutely right. Moving to the next question. If the radius of the first Bohr orbit is x, then de Broglie's wavelength of the electron in the third orbit is nearly what? Yes, if the radius is x, then according to de Broglie's relation, then the wavelength of the third orbit electron will be what? According to the concept of de Broglie's relation, you can find out, substitute in de Broglie's relation and come to the correct answer. It should come 6px, that is 6 times of momentum into the radius x. Moving to the next question. The orbital angular momentum of a d orbital electron is given by. Orbital angular momentum for the electron present in the d orbital is given by the relation, because d orbital will be under root 6 into h upon 2 pi. Okay. Next question. The number of radial nodes in 3s and 2p respectively are. I told you that radial nodes are calculated as what? What is the formula to calculate radial nodes? It is n minus l minus 1. Now I will take for 3s. In 3s, n is equal to 3, l is equal to 0. So 3 minus 0 minus 1, that will be 2. Yes. Similarly, you have to find out for 2p. For 2p, n is equal to 2, l is equal to 1 minus 1. So minus 1 because minus 2. So what is the relation? It will be 2 and 0. Okay. Remember the formula to find out radial nodes. I am repeating it again and again. Radial nodes is equal to n minus l minus 1. And what are the number of nodes equal to? N minus 1. What are angular nodes equal to? Only L, that is azimuthal quantum number. L value decides the angular nodes. Okay, moving to the next question. A hydrogen-like species in the fourth orbit has a radius 1.5 times that of Bohr's orbit in neutral state. Its valence electron is in. Okay, when the hydrogen-like species in the fourth orbit has the radius 1.5 times that of its orbit, in the valence electron will be what? Choice C should come. It should, the electron should be present in the 3s orbital or 3s subshell. Next question. Following suborbits with the values of n and l are given. Let us see one by one choice, okay. You have to find out the subshell to which the electron belongs to and then decide the energy levels. When n is equal to 4, L is equal to 1, which subshell it belongs to? N is equal to 4 means 4 is the number of the shell, L is equal to 1, that means which subshell it belongs to? P. So first is 4p orbital or 4p subshell. Second is 4n 0. So it will be 4s because L is equal to 0 means S. 3 and 2, that is 2 is for what? D. Yes, 2 is for D. So 3D subshell. And then last is 3 and 1. So it will be what? 3p. So what is the energy levels? If you look at the choices, what will be the order of the energy level? The energy level 4 will be less than 2 will be less than 3 will be less than 1. That is based on Aufbau's principle or n plus L rule for deciding the energy levels of the subshell. So choice C is the correct answer. Moving to the next question, students. For chromium 24, the electronic configuration is generalized given as argon. When they say argon means 18 electrons, atomic number of argon is 18. So out of 24 electrons, 18 are given to argon. The rest of the configuration is 4s1 3d5. Okay, that is the ground state configuration. The number of electrons with L is equal to 1 to L is equal to 2 are what? Yes, respectively. So if you see that for chromium, which will be the correct answer? Choice B, that is with 12 and 5 respectively. If you just substitute and find out the values of L given to you, and then you can do this very simply, students. You know how to do it using the quantum number concept. Moving to the next question. Last filling electron in lanthanides find place in 4f orbitals. We know that lanthanides and actinides are placed in the 4f and 5f orbitals respectively. Then which of the following sets of quantum numbers is correct for an electron in the 4f orbital? In the 4f orbital, n should be equal to 4. Remember, n should be equal to 4. F, that means F subshell, that is L should be equal to 3. Okay. So from the choices, you have to just decide which two choices is having or which choice is having n is equal to 4 and L is equal to 3. Most appropriate is choice C because not only n and L values are corresponding but also value of m and s are corresponding for the 4f orbital of an lanthanide element. Moving to the next question. Select the correct statement. Mod of psi square measures the electron probability density at a point in any atom. That is the correct statement for mode of psi square. Okay. All of the choices, let us see. All of the choices you can see psi and mode of psi square as a function of the three coordinates of radius q and the angular part, that is f. Third choice says that angular wave function depends as on L and m and is independent of n. All of the above are correct according to Schrodinger's equation for finding out the probability of an substance at any point in an atom. Okay. So choice D is the correct answer. Moving to the next question. Which orbital gives an electron a greater probability being found close to the nucleus? Which is the atom, which is the shell which is closer to the nucleus? Yes, the S subshell will be closer to the nucleus as compared to P, D and F. So 3s is closer to the nucleus. So 3s is the correct answer, choice C. Next question. Hamiltonian operator H bar, Hamiltonian operator is the sum of two energy operators. Which are the two energy operators? That is kinetic energy and potential energy. Hamilton operator is the sum of kinetic and potential energy, that is choice C.